Good afternoon, friends. Welcome to the STP training webinar series. The topic for which is 5 secrets for simplifying your automated cases. Our speaker for the day is Paul Merrill. I'm Smita Mishra, a professional tester myself. I'm excited to host you all and Paul on our STP webinars. Quick information for all of you. The next upcoming conference we have is Fall 2019 STPCon, which will be held at Boston from September 23rd to 26th in 2019. It is the 10th year anniversary of STPCon, and we have supported testers for 10 solid years and built a thriving community of theirs in our own way. And we would really like for all of you to join us at the event. The keynotes have been selected and announced. You can look them up at stpcon.com. We have the world famous automation leader, Angie Jones, the automation and testing leader, Dorothy Graham, a world-renowned speaker and a bright technopreneur, Kevin Suarez. And finally, we have the hugely popular testing leader, a mentor to many, and our very own Mike Lyles as the keynote. The entire program is up for your review and registration. You can view the same at stpcon.com/event-schedule. The link is up on the screen. The topics range across automation, AI, machine learning, DevOps, performance testing, leadership, mobile testing, security, and so much more. So if you plan to attend the upcoming conference, also do not forget there are various discounts and offers for alumni attendees and team registrations. If you have queries, do email them at info@softwaretestpro.com. So, Paul, you are a regular speaker at STP, and I know that you are coming back to the fall program to present again. So your topic, refactoring for those who don't code, looks very interesting to me. So tell us more about what it is.
Hey, Smita, and thanks everybody for having me. Thank you, Smita, and thanks STP. I always appreciate having the opportunity to do these things and speak with everybody. And I really appreciate the opportunity to come and speak at STPCon again. I've done it for a number of years. It hasn't been every single year, but I think it's been three years or maybe 4 years now. And it's a great conference. I always meet cool people and I always learn lots of stuff. So I'm honored to get the chance to be there again this year. But the talk, refactoring for those who don't code, you know, I learned a long time ago as starting out as a developer that one of the key concepts, one of the key practices for me to write good code was to refactor. And I think that most of us in the testing world probably hear that word all the time, but may not have any idea what it means. And so what I wanted to do was to take the concepts of refactoring and allow folks who don't code to understand what they are, so that when they go back to their teams and they start working with their developers and they hear the word refactoring, they know exactly what that means, how it could help them, and what it means for them as they move forward.
It actually looks absolutely exciting to me because I have never heard about this topic being discussed between amongst the testers. So I'm sure going to attend it. And so also, since the program is out now, did you get a chance to look at the overall program schedule and any particular ones that you are looking forward to attend?
Yeah, so I mean, STP has so many great speakers, and I always love going and getting to see you, Smita. I love getting to see you. I love getting to see Mike. I love that Mark is there so often, Mark Tomlinson, and so many others that I probably won't be able to name, but Melissa and many others. I always love getting to see those folks. This year, I've taken a little bit of a different approach. So I actually spent some time this past week looking or having someone write down all the names of the folks and just seeing who was there. And so I'm going to be looking for people who are new that I've never heard from before and listening to their perspectives and trying to understand what it is they're seeing that's different from me and how can I incorporate that into what we do at Beaufort Fairmont. So that's my approach. Thomas Haver is there, and he's one of the smartest people. I mean, there's so many smart people there, but Thomas is so much fun to talk to. He's incredibly smart. He has a wonderful view, I think, of management and great values regarding management and how we organize our testing groups, but also incredibly smart about test automation. So he's one of those that I'll be looking at, and I've talked to him and met him several times. I like him a lot. But I'm looking for new folks. So I'm going to be looking through that list of just who I haven't seen before. I am interested in the, you're going to have to help me with the name, but it's the gentleman from Advance.
Kevin Suarez.
Yes. Yep.
Yes. Yeah, absolutely. That ways, STP is one of the conferences where you definitely have a lot of good speakers and new speakers also coming up. So you sure are going to have a good list of people.
Yeah, and there were so many great topics there. I don't remember the topic off the top of my head that I was looking at, but this year my approach is just going to be find people I haven't met before, listen to them, and see what they have to say. I think that's one of the best things about this industry. There are always new voices coming out. They're different than mine. They have different perspectives, and I want to learn from them.
Moving forward to our webinar today, so stay tuned for more webinars coming up. We have some exciting topics and superb speakers coming up for you. And if you are on Twitter, please share the conference information and about this webinar with your followers and connections. You can also add STP's Twitter handle to your tweets, which is at Software Test Pro. You can also please note down the speaker's Twitter handle today. So Paul's Twitter handle is @Merrill. You could add him on your tweets. All right, let's get started with the webinar today. A very warm welcome, Paul. We are very excited to have you with us today. And let me quickly introduce you for all of us here. So Paul Merrill is a principal software engineer in test and founder of Beaufort, Fairmont Test Automation. Frequent writer on testing and test automation in top-notch testing publications and international speaker. Paul works with clients every day to accelerate testing, mitigate risks, and increase the value of testing processes with test automation. An entrepreneur, tester, and software engineer, Paul has a unique perspective on launching and maintaining quality products. So follow Paul on Twitter for testing insights. Learn more about test automation at beaufortfairmont.com/webinars. So you can look at his company webinars for more insights on testing. Okay, testing people, let's get started with the discussion on simplifying your automated test cases. Very warm welcome again, Paul, and the floor is all yours. So,
Hey, thank you very much. I
hand over.
appreciate that welcome. And once again, it's always nice to be here with you all, and I appreciate the opportunity. Today, we're going to talk about 5 secrets to simplifying your automated tests. I have never done this talk before. I've never done it, so this is brand new stuff for you guys. If you've seen me speak before or seen our webinars, you know that maybe I've touched on some of these subjects. Maybe I have done things or said things that could help you with your automation. I think these 5 secrets are really the linchpin of writing great test automation, and I hope you get something out of it today. Once again, my name is Paul Merrill. I'm from Beaufort Fairmont Automated Testing Services. We're based in Cary, North Carolina, and we help companies learn how to do test automation. We help them with their challenges in test automation. And automated testing, test automation is so big right now as companies are establishing cultures of DevOps, as they're working on building up their practices that make a DevOps culture work. Test automation is a key part of that, and fast feedback is a key part of that. And in order for that to work, we have to get to where we are simplifying our automated tests. There aren't a lot of slides in this slideshow. You are looking at the first slide, and I will switch slides when it comes, but I just want you to know there aren't a ton of them here. So we're not stuck, everything is fine. So first of all, I guess what I want to do is kind of talk through why simplify. Why is it that we're going to simplify our test cases? And why is it that I'm talking about it today? If you know me, if you've seen any of my talks, if you've read any of my work, I'm always talking about why. I tend to like to start with why. I'm a very big why person. When we work with clients consulting, or for our dedicated experts working with clients on their automation, we spend some time with them to try to understand what it is they're trying to achieve and how it is they've gone about it so far. And without that, we can't really understand how to move forward. So we're asking them why. Why simplify? A lot of that, and a lot of this talk today is very selfish. So I don't know if you've had this experience, but I know for myself, I have looked at suite after suite after suite of thousands of automated test cases with one client after the next. And they're all so complicated. They're all so long. They're these giant long test cases with 100 steps to them, if not more. And when I read through them, my eyes glaze over and I start to drool a little bit. It's really quite terrible. But I think so many companies approach test automation that way, that what we'll do is they say, let's take what we do manually and let's convert it one-to-one over to automated testing. And that can be the worst approach you could do. Most of the time when we're called in to work with teams, they've already tried automation. And if they don't have a suite of 1,000 or 3,000 automated tests written against the UI only, then they definitely have a suite of test cases that they've written as manual steps, and that they want to take those and convert them over. What I find with these is not only that they're long, but generally they don't work. Generally, whether it's the manual test cases or the automated ones, no one's looked through 3,000 test cases anytime recently. And if they have, the effort that they found to go through and audit what's there and understand how it helps us is too big of an effort for them to actually continue and to get value out of. What tends to happen is during this process of converting from manual to automated tests, we find out how much work there is to do. And we find out that some of these tests don't make sense or that we don't understand them. So I want to bring that back a little bit and talk about simplifying test cases. It's selfish. I don't want to look at long test cases when you guys bring me into your groups. That's one reason. But I also want you to be able to understand what's going on there. So a couple of things here. Why do we want to simplify test cases? Well, number one, all the time I hear our automated tests are flaky. I've even heard such things as Selenium is flaky. And many times it's not Selenium that's flaky. And oh, by the way, test automation is more than just using Selenium. There are a lot of other avenues to do test automation in. But the flakiness isn't there because of the tool. The flakiness isn't there because of the test case we're trying to do, the steps that we're trying to do. The flakiness comes from several different reasons. The flakiness comes from the data we're using. It comes from asynchronous processes on a UI in this new world of highly responsive, I say new, it's 6-7 years old now, right? This world of highly responsive web applications, single page web applications. Flakiness comes from a lot of things. Flakiness can come from poor applications. When we write applications that just don't work the same way every time you interact with them. Flakiness can come from a poor UI. It can come from bad test code. That's the one that probably is the second most often reason that I see for flakiness. Bad test code. The first would be the data we use. And finally, it can come from a lack of understanding how to code. So often in our environments, we ask people who don't code, who may not even want to code, to start writing automation, and we don't know the basics of the language we're using. I find this very, very often. If we're gonna be craftsmen, if we're gonna be people who do a craft, if we're gonna work on test automation, we have to know our tools and we have to know them inside and out. So learn the basics of the language you're working in. But why simplify? Well, we want our tests to run more effectively. We want them to be credible, right? We want them to be robust. We want them to work every time we run them. We want them to be repeatable. We want the maintenance to be low. This is one of the most overlooked pieces of planning and setting up test automation. It's easy to overlook the amount of maintenance we're going to have when we build out our test automation tools, frameworks, and other pieces of code. Maintenance on test cases can take a long, long time. I find so often that what we expect out of developers, we don't expect out of ourselves. Many times we see developers commit code, we look at it, we see it build, and it doesn't work with the very first use case that we try, the most basic use case. And we get frustrated as testers. How could you write a piece of code that doesn't even work with the most basic test that I could possibly do? The first one that I thought of it didn't work on, and you committed it and you think that it's okay? But I see that with test automation engineers a lot. I see it a whole lot. I see test automation engineers doing exactly the same thing, and sometimes worse. So many times we're writing bad code ourselves and we don't know how to write better code. and that causes lots of maintenance. Trying to figure out whether it's the test code or it's the application code, if it's a change in the infrastructure, if there's something else going on, if we've got a service, a third-party service that's down, all of that troubleshooting takes time. And the more time we take to figure out what's going on, the less valuable our test cases become. We want fast, quick feedback from our test automation. And finally, I've got this word down there, triangulation. It's a big, scary word. I use it the same way that Kent Beck used it in his TDD book. He wrote a wonderful book called Test-Driven Development by Example. It came out a long time ago. It is as good today as it's ever been. It's a wonderful book. I think that anyone who writes code relative to testing, you do any kind of testing and you write code for it, go read that book, do all the examples, learn exactly what he's saying in that book. Triangulation is one concept he covers in there. The idea that we have a test case that's over here working on this part of the system, we have a test case that's over here working on this part of the system, and one over there, we can help identify where a defect is if we have the right test cases, if we understand what they cover. For instance, let's say that you have those 3 test cases in running against different parts of the system, different feature sets, different parts of the architecture, whatever it is. If all of them pass and we still have a defect that we know about through other means, we know that we don't have a test case covering a piece of the system. Well, we can look at the coverage from our test cases, see the part that's not covered, and make a pretty good guess about where the problem is. It's probably in the code that's not covered. Further, if you have lots of small tests, one of them fails and the others don't, it can help you identify very quickly where a problem is. I think a lot of folks do not think about development as a customer as test. So as testers, one of the things that we can do if we want to is to look at development and say, hey, I want to make you satisfied. I want to make you happy. I want to make sure that you can do your job better. What can I do to help with that? We can write our test in a certain way so that developers can get faster feedback. Because even though it's easy to forget, developers and testers want the same things. We want our customers to be satisfied. We want to be satisfied in our jobs. We want to feel good about what we produce. And we want to put out a high quality product that makes people happy. Most of the time, 1 or 2 of those things are the same between us and developers, but it's easy to forget. So why simplify? Because we want to deal with this. We want to get rid of flakiness. We want to get rid of as much maintenance as possible. We want to be able to troubleshoot fast, and we want to be able to find out where it is that there's a problem within our tests. So the first secret, I'm giving you the secrets, okay? Don't tell anybody after this. Decrease scope. So number 1 is decrease scope. So what do we mean by scope? Scope is the idea of the area of responsibility, the area of interaction that a test case has with the application under test. So I say application under test. It may be a service, it may be a system, it may be something else. But there is something that we're testing. That thing is under test. So if it's an application under test, that's what I mean there. So the scope for an end-to-end test might be one nice horizontal run through the application. For instance, something like creating a user and buying a product on a retail site. That would be one chunk of work. It's end-to-end. There's a human being at one end. There's something at the other end that does an exchange, that does a transaction of some type. There's data that gets written and updated during that time. It's a nice long piece of work. That's the scope of that test case. It's an end-to-end kind of thing. The scope is to figure out something related to doing this purchase or creating an order. When I'm talking about decreasing scope, what I mean is, in the example that I just gave, there are a lot of things going on. The scope is very, very big. We think of what all we have to go through there. We're finding out, does our user work? Does our password work? Can we navigate where we need to navigate to? Does the cart system work? Do the services related to orders work? Does inventory work? Does our shipping and delivery work? The scope is huge. Do our transactions, our payments, does our payment system work? That's a very, very big scope. So I like to think about decreasing scope with tests. So these are a couple of keys to decreasing the scope. as I was talking through this, I was talking mainly in this fourth item here, feature sets. So the feature of ordering, the feature of inventory management, the feature of payments, the feature of login, lots of different features there. You could also break this down architecturally, and I think that this is the one that's the least attainable to us as testers. We don't know how to think architecturally. We haven't been exposed to it. Developers have. So this is one where we might pair up with our partners in development and say, tell me about the architecture of the system. Where are the boundaries for the system? And they might say, okay, well, we actually don't handle payments ourselves, you know. You say, I never even thought of that. Yeah, we call out to PayPal to do that, or we call out to Visa or MasterCard to do that. They handle all of our payments. So that's not actually a part of our system. So when you're testing that, you're actually testing a third-party system, which may very well be tested robustly by that third-party provider. It may not be something that we need to worry as much about. It may not be the highest risk item in our system. So as we're looking through our test and we're saying, okay, well, we did all these different things and payment was one part of it. Maybe I don't need to think about payment as much in this test. Maybe I can kind of narrow my scope a little bit. In terms of architecture, we can think in terms of logical or physical architecture and where those boundaries are. We can think in terms of where the databases are, where the file systems are, where other services are. And once we get up on a whiteboard and we draw these things out with our partners in development and ask, where is such and such happening? Where is this part happening? We can start to see, oh, this is what's in our application code and this is what's not in our application code. And then as testers, we can come back and say, what's important to us to test? What's important to us to isolate risk or to mitigate risk? What are those things for us? But until we do those activities, we can't get there. And when we start to decrease the scope by looking at architecture, the data model, for instance, the different systems involved, different feature sets, and where the boundaries are, we start to come down to a smaller and smaller test case. And the reason that that's good, the reason that I like that, is because the smaller the test case, the less maintenance there is, the less code there is to worry about, the less complexity there is, the less thinking I have to do when I look at it. Everything gets smaller and smaller. The quicker the feedback for it, since it executes faster, is more robust, more easily reproducible and rerunnable, the easier it is for me to run it multiple times, to run it often, which means the better the test gets because I experience failure related to that test more often. Hopefully those things make sense. The more we do something, the better we get at it, right? We practice with a lot of things in life. We'll practice with our learning a new sport or learning a new game or learning a new set of behaviors. But we rarely practice with our automated tests and with our systems in testing. Let's practice, let's get better at them. Let's run these tests often and quickly in order to find out when they work, when they don't work, what's causing that. And we can do that by simplifying them and doing step number one, secret number one, decrease scope. Step number two, I hope you're taking notes. There's actually speaking of notes, I have a cheat sheet out on the Beaufort Fairmont website. It's the 5 ways to simplify your test cases cheat sheet. You can actually look it up on Google. If you do 5 ways to simplify test cases and cheat sheet, it'll come up first. And you can download a printout of these 5 reasons, or just look it up on our website, do a search on there. But reason number 2 is fail for one and only one reason. So a test case, many of the times when I look at them, these automated test cases with our clients, what I see is a lot of validation points, a lot of verification points, lots of checks, whatever you want to call them. And then there are a lot of cases, test cases, where there are none of those. So I rarely find test cases that are nice, succinct, small test cases with a clear scope that's smaller and also fails for one and only one reason. Now, why do I say fail for one and only one reason? Because I want to know why the test case failed after execution at a glance. At a glance. And oh, by the way, in terms of what I believe and what I like to do, I don't always get to do what I like to do with clients, but what I like to do with clients is I like to only have 2 states to a test that has been executed. Pass or fail. 2 states. That makes it really simple. There's no thinking about it. It either worked or it didn't work. And if it kind of worked, but not really, that fits in the don't work pattern, right? Like there's only 2 ways. It ran part of the way and it validated part of, nope, that didn't work. It either worked completely or it didn't work. 2 states. But I like to look at a test case or a report on test cases and know immediately, did it fail and why? That gets much easier when there's only one reason that a test case can fail. So take our example of the retail situation. If we had a test case that did all the things I mentioned, you log in, you go through navigation, you pick an item, you put it in the cart, you click on the cart, you go in and you pay, you go through a payment thing, whatever. If it fails, do I know why it failed? Just by looking at the name of it, the test was make an order, right? I have no idea. I guess an order didn't work, but that doesn't really tell me the reason that an order didn't work. On the other hand, if I have something like check that inventory cannot be negative and it fails, I know that the inventory for an item somehow went negative, and that's not right. And as I can trace down to that, it's very easy to find where the problem is, or much easier than if we had a much bigger test case. Now, I'm not saying don't have any end-to-end test cases. You're gonna need those. You're gonna need those at some point, but they're harder to maintain, they're harder to work with, they take more time to execute, they encompass more data, they have more dependencies, they're much more difficult to work with. So simplify your test cases, get to a point where each test case has one and only one reason to fail. You'll actually find very quickly that it's easier to name the test case, it's easier to look at a report and know what happened, and you have less hunting and less time trying to figure out why a test case failed. We go back to what we were talking about earlier in this when we were talking about why simplify, and I talked a little bit about maintenance. That maintenance is vastly overlooked in terms of planning out your automation approach. The maintenance, in my mind, also includes the activity of hunting for why a test case failed. That takes a lot of time. In fact, it takes so much time that it's rarely done with most folks that do automation. We also rarely assign that role within our organizations. Who is it that's going to look and see why test cases failed? Especially when we're in a CI/CD environment, or we've got a pipeline where these are running multiple times a day, or we're running many tests overnight. We want to know without much work why something failed. We've all got too many distractions, too many things going on, too many telemarketers calling us with robots, too many Slack notifications or whatever it is to spend our time hunting for the reason that a test case failed. Let's just make it known by the name and by the assertions or validations in that test case. Secret number 3, identify responsibility. I don't know who this guy is. He reminds me of someone on a commercial for a beer. I forget which one it was. Wish I could remember that. So anyway, but what a wonderful picture, right? All these pictures are from Unsplash. I don't know if you take a moment, if you like art, if you like photography, but Unsplash is a great way for photographers to expose some of their work to the public. I've gotten they're free to use, the images are free to use, and there's just some wonderful stuff up there. So I saw this and thought it would work for identifying responsibility. So what does that mean with regard to simplifying test cases? So first and foremost, so often I find when I ask a team, okay, you just wrote this test case, it's a manual test case, what is its responsibility? I find blank stares. I find people looking at me, it's like I'm speaking a different language. I don't know if you guys have experienced this with your own tests, where you sat down and you said, I wonder why this test was written, what it was supposed to do, what its job was, and get back and realize, you know what, I don't know that anyone's ever thought about what the job of this test case is. Identify responsibility. So what is the job that this test case is supposed to do? We talked about the end-to-end test case of making an order in a retail system. Clearly, the responsibility of an end-to-end test in that case would have something to do with making sure that all the systems work together, that we had a system level test that was testing the UI, it was testing all the systems involved, and there's a lot of responsibility there. As we start simplifying our test cases and looking for ones that can help us identify what's going on in the system today, we also need to identify what their specific responsibility is. So I could see a suite of tests just for ordering. Can we get the inventory we want? Is that product still available? Has it been discontinued? Do we have it in stock? When can we get it in stock? How do we make an order from our suppliers for it? When will the customer get it? There are many test cases that I see for just the ordering aspect of what we talked about before. And as I identify the responsibilities that I want the application to have and that I don't want it to have, it helps me identify what the test cases are, and vice versa sometimes. So what is the responsibility for this test case? What is its job? If you can't answer that question, chances are you've got a test case that needs some work, whether it's automated or manual, doesn't matter. So often I talk with folks and ask, where did this test case come from? What is it doing? And so often we don't know. I'm sure you've experienced that, looking at some test case that somebody 5 years ago wrote, and we look at it and we say, I don't know what the gray button is. And on that screen, on that page, there is no longer a gray button because the world has moved on. One of the keys as well to some of the simplification is taking a strategy of using the imperative voice with our testing versus the declarative. So take a look at that sometime with imperative versus declarative tests. The declarative would very much, and I may have gotten this back, sorry, writing declarative rather than imperative. The imperative ones would say, click on the green button, whereas the declarative ones would say, order new shoes. So we want meaning in our test cases. We want to communicate with our test cases, and we want to make sure that we are able to gain from them what we need from them, as well as our developer friends and partners. So what is extra in this test case? When you're looking at it, what's here that doesn't belong? Is there navigation that we could skip by having a session token that would allow us to just skip screens and skip navigation? What's extra in here? Is there setup involved that may make it confusing to a reader later? Have we identified what the setup for this test case is? Have we made that clear, that old pattern of arrange, act, and assert, the 3 A's from I can't remember the name right now, but I wrote it down specific for this presentation. But those 3 A's within test cases: arrange your data, arrange your system in such a way that you can do the test that you want to do. Then go in and act on the system to try to stimulate it in such a way that it produces a behavior that you were wondering what would happen. And then finally, assert. So assert that it works the way that you think. Create a verification point or a check of some kind. So identify responsibility for your tests. The more you start to try to find the responsibility for your tests, the easier it's going to be to name them, the easier it's going to be to read them, the easier it's going to be to understand, and for someone to come back later and understand why this test is here. What is its responsibility? This is one that also came out of the XP world. So the idea of that last concept of identify responsibility and some of the comments that I had there, the 3 A's came from the XP world. The simplest thing that could work, I believe I heard this from Ward Cunningham 20 years ago. It may have been with Kent Beck and others with his book on extreme programming. But we used to have this idea of what is the simplest thing that could possibly work within the extreme programming world, one of the earlier agile methodologies. We would be faced with a problem. For instance, let's make sure that we can deploy our code out to the system under test. What's the simplest thing that could possibly work? And I remember that exact problem within the first extreme programming environment that we were in. And we had to figure out how to deploy our code. This was long before we had CI systems and whatever else. Or the ones that were there were not good, but it was a long time before most of these came out. And we actually just went in and used the tools that were available to us. We used Ant scripts calling into Bash scripts that were SCPing files from one system to the next. And then when they were there, automatically run other tools to get the system in shape that it could actually run the code. The simplest thing that could possibly work. Nothing about that sounded simple, I'm sure, but each step of it was. We knew that we knew SCP. It was easy for us. We knew that it was just one command that we could put into a Bash script. We understood Bash and command line tools. That was easy for us. We were already using Ant. Those were the simple things. Writing a new application to do deployment, writing our own Puppet or Ansible or whatever, that wasn't even something that we could even consider then. Now, if we'd thought about it enough, maybe we could have done it at that time, but that would not have been the simplest thing that could possibly work. With testing, this is very much the same thing. So often I see us going the hardest way to do something when there's a simple way right in front of us that could work. And I think this comes from several things. I think that for many testers, we like things as a whole. We are wholesome people. We like to see whole and completeness. I think that's a part of our makeup. I think we do testing because we're like that. We don't become like that because we do testing. We do what we are, not the other way around. I think as testers, many of us like to see completeness. And so when we come to a solution, we want the best, most complete, most pre-planned, most thought out, most robust solution we can possibly come up with. That makes a lot of sense. I think everybody would like that. The problem is you don't know what it is. You don't know what it is. You're probably not going to know what it is until after you've written several solutions that didn't work well. And it's too complicated and doesn't fit into our budget and doesn't provide enough value for us to do right now anyway. So why not take a more agile approach and be iterative? What's the simplest thing that could work today? What can we do today to get past whatever problem's in front of us? So fine, we're working the system, we're creating a new Selenium script to go in and do this ordering on a retail system that we were talking about. We want it to just do ordering, but for some reason we have to log in. What's the simplest way to get around that? Oh, well, I can go get a new token and I can log in by just having a session token in my header and go straight to the ordering page and get that done. That may not seem simple to you, but if you've done it before, that's a very simple solution. What's the simplest thing we could do in terms of getting an order set up? Well, you know, they've got these APIs out there that we could use. I guess we could just call in and get a specific kind of item we want, passing a query into that API. And then we know the order, the item number, the SKU, and we can just automatically add that into our test. We can grab it in our test and go use it. That may not sound simple to some folks, but to others, they're going, you know what? Yeah, I could just use the API to set up the data. That would be really easy. We don't necessarily have to go in and query the database and go through the system and go through searches maybe on the screen that are these big, long, complicated searches. There may be more simple ways to do it. The things that come from simple are they focus us on growth. So when we take a solution that's not quite perfect, understanding we don't have a perfect solution because nobody does, we're committed to growth. We know we're going to have to come back later and make it better. And that's the way things work. You're going to come back later and make it better. That's okay. Let's put ourselves in a position that we can come back later and make it better. Later when we know more about the system, later when we know more about the test case, later when we know more about the language that we're using to program in. Come back later and fix some of these things. Now, I'm not saying avoid obvious problems that are in your path that you know a simple solution to. I'm saying use that, but don't go all out trying to find the best solution that could ever be when a simple one will suffice. Less steps. You have less steps in your test cases, less developing time. This is something that's overlooked so often, I think. The time that it takes to develop a test case. There's a lot of learning that has to go on there. There's a lot of things that have to go on in developing a piece of automated testing or test automation. There's less time to execute. Usually, the simpler you get, the faster things get. Avoid dependencies. So the fifth secret, avoid dependencies. Now, this is one that I think everybody, a lot of people that have done test automation once or twice, they know. But if you haven't been there before, this may be brand new to you. So I want to make sure to call it out. The idea here is that many times what I see is I'll see one test case written that goes in and it makes an order successfully. And then the next test case comes in and it checks to make sure that that order shows up in a log file or something, maybe in a report somewhere. And then the next test case comes in and makes sure that as we change the timer over to next month, that report no longer shows that that order was built in the last one, right? So here are 3 test cases that I just gave you, where each one depends on the result of the other. Now what happens? A lot like dominoes. When you stand up dominoes, one of those fails, it causes the next to fail, it causes the next to fail. And soon you've got this big mess of red fail in front of you. You have no idea where it came from. And you might say, well, I know it's because the first test case failed. Well, do you? It could have been a lot of things. And do you know why that first test case failed? Do you want to have all of your test cases fail because something unrelated failed, like you made an order over here and the reporting on orders to fail, I don't really want that. I want to know that the report works, and I want to know that ordering works. And I want to know also at some point, I want to know all of them together in one test case, that when I make an order, I also get a report with that order in it. But that's a different test. I also want to check all the details of an order and what I can do with it, what I'm not supposed to do with it, and does all of that work. On the other hand, the same thing with the reporting. I want to bring up reports. I want to put in a month that's not correct. I want to put in a year that's already, that hasn't happened yet. I want to put in a year that's not even in the Gregorian calendar. I want to do all of these things within a narrower window, within smaller scope, and I don't want anything else to depend on it. I don't want to go in and change data for a report in one test case and then use it in another. I don't want those dependencies. Now, there are a lot of other kinds of dependencies. This is one test depending on another, was the one that I talked about already. But lengthy external processes. So this is my catch-all here. Lengthy external processes. Things like refreshing a database from production. We might have to do that, but how often do we think of alternatives to that? Is there a simpler alternative to this? Could we do something? Could we mock out a piece of the test case? Could we mock out a piece of the system under test? Could we use service virtualization? What can we do to make this test system more effective, to give us more information about what the system is doing faster, and give our partners and customers in development more information that's more accurate, more credible, that they can use faster to make a better product? Because when we're doing those things, when we're faster in testing, the company gets faster. And when the company gets faster, everything tends to move forward and get better from there. You get your bonus after that, right? Good things start to happen. So there are a lot of dependencies that we may or may not think of. Third-party systems, there's specialized knowledge as a dependency. I was thinking about this today. How often do we look at a test case and we see that there's some specialized knowledge built into it, some mystic thing that's going on in there, some secret formula that they're doing in this test case that makes it all work? The person who wrote the test case knows it, but you don't know it. So now we've got this dependency on a human being. I have to go ask Clark what exactly he was thinking when he built this test case. What is that special knowledge that you have that I don't see here? That takes time. That's not test automation. That's human testing. We want to do things with humans, but we want to make humans do the things that humans do well, and we want computers to do the things that computers do well. So those are the 5 secrets to simplifying test cases. I mentioned a cheat sheet. There's a link for it here. Take a picture on your phone or go to our website. You can go to beaufortfairmont.com and look on the blogs for cheat sheet or 5 ways, and you ought to be able to find it very quickly. You can look on Google and find it as well. But this cheat sheet is something you can print out, put it on the wall of your office or your cube or your open area workspace, and have it there for anybody to see. It has all 5 of these reasons on it. Go download it and have it available to you. Once again, my name is Paul Merrill. I'm from Beaufort Fairmont Automated Testing Services. We help companies through consulting, planning out their work with automation. We help companies through training, things like methodologies, specific tools, languages, other behaviors as well, customized training as well. And finally, we help companies with our dedicated experts. We have people that can work with you on an ongoing basis, embedded with your team, to help your automation and your CI/CD, DevOps transitions go better. So thank you so much for having me. I've got my Twitter address there too. And Smita, thank you very much.
Thank you, Paul. That was pretty insightful. We do have a couple of questions. I'm going to run them quickly through you. So the first one is, on your point number 2, which probably said fail for one. Sorry, did it? Okay. So on your number 2, which said fail for one reason only, are you how do you expect testers to test using user stories, or are you suggesting a step-level test case?
I think you can do it for both. So usually a user story has one specific reason that it exists. There are other reasons that it may encompass, and it may have different specifications that go along with it. But in the case that we have a user story like, like the one that we were talking about, as a customer of the retail ordering system, I want to be able to select an order and purchase it so that I can enjoy that product. I don't know if that's a good user story or not, but in that case, can I get the product? That would be the one reason that it would fail or not. Can I get the product? I don't want to fail because I couldn't log in. I don't want to fail because of all these other weird reasons. I want to fail because I either got the order or not. In the case of smaller steps, I mean, I'm not talking about step definitions that fail or not. I'm talking about specific tests. So we're going to have, hopefully in our environments, we're going to have all different levels of tests for different reasons. We have end-to-end tests for one reason. We have integration tests for one reason. We have service level tests for one reason. We have unit tests for one reason. Each of those test cases has a reason for being. An integration test, we want to make sure that two systems work. So when we write a test for that, we want it to fail for one and only one reason. And that one reason might be the two tests do not talk, right? Like I want it to be a very specific reason that the test case fails. What I don't want is to fail, for instance, in a UI test, the one that we've been talking about. I don't want to be failing because the navigation didn't work. Lots of people write verification points or checks within their navigation of systems. I don't want to fail because the navigation didn't work when I'm really trying to see, do all the systems work together to create an order? Hopefully that's an answer that makes sense to you.
Yes, that makes sense, Paul. And quickly, one related question on the same topic was, and meanwhile, if you can showcase your cheat sheet link, there are people asking to note that down. Yeah. So yes, thank you. So the next question is, you mentioned that you would prefer to have pass and fail results, like just have pass and just have fail. So how do you handle those kind of situations where you realize features, these are features, not defects? So are you wanting testers to not inspect and explore and say, okay, it's not matching what I wanted it to be, so it's fail for now, let me just put it fail, and then have a discussion with devs? Or is it okay for them to, would it be better for them to explore it at their end?
So there's a whole lot going on in that question, right? So number one, one thing that I didn't mention that I should have mentioned up front is my position on test automation is that automated test cases can only do two things. This is from Michael Feathers, they can only detect change in a system. So something's changed and so it detects that, or they can detect correctness. And there's a little asterisk by that, a footnote that says correctness in the sense that we knew correctly what was supposed to be correct to begin with. Those are the only two things that we can know about with test automation. So we need something else to do other testing, things like exploratory testing. Those are things that humans do very well. Machines don't do that very well. If there's a feature that's missing, a piece of automation isn't going to know that. It can't know that. The only way that it can know that is if we're doing TDD or ATDD, where we've got acceptance testing. So we write a test case that's supposed to test a feature, but the feature isn't there yet, and it fails until the feature is there. So yeah, even in the case that a feature isn't there, if you've written a test case and it fails because the feature isn't there yet, I think that's great. It may not be one that you want to run all the time in your CI/CD pipeline. You may want to take it out until the feature has supposedly been created and then run it in your CI/CD pipeline to see if the feature is correct. But sure, I have absolutely no problem with the case where a feature has not yet been created. Smita, I am listening to the question, so I'm not sure that I got all of that. Were there pieces that I missed?
That makes perfect sense, because with reference to automation testing, that's perfectly well, putting it on pass and fail, and then letting the the testing part to be left at the exploratory side where you have the discussions going on. Yeah.
And a lot of people want some third state where there was an error that was caused by the system. But to me, if the system's causing an error when we're doing something and we didn't expect it to cause an error, that's a failure. That's a failure. Or if the system's not there, well, something should have failed to tell us that, the system wasn't there. Hopefully we had some kind of smoke test or something that said, is the system there? Do we get a 200 back from this request or something?
Absolutely. Those are the kinds, then they say, works on my system kind of situation.
And that's a big part of automation, is getting away from what works on my system. And this is the biggest thing for me. I get so jazzed up about this, so forgive me if and just tell me to shut up if I'm going too far, Smith. But for me, one of the things I get so excited about is test automation that isn't run in a CI/CD platform. It's just missing 90% of the reason that you would do automation. You get so much more out of that because you finally have a system of truth. You've got some agent, some system that's running, that CI is running against to find out if it's right. Everybody who runs those pieces of automation on their own machines, everyone who runs those automation tools on their own, if it's failing there, you can look at the CI/CD system and you've got a difference of two systems, and you can find out what's the difference between it passing there and failing here and identify where the problem is. That's absolutely key. And then when you have more systems, 2 automation engineers and a CI/CD system, or 2 or 3 different agents running in different pre-prod levels, now you can start to see, oh yeah, well, in our staging environment, we're actually tapped into a real payment provider, whereas we mocked that out in the lower environments, and that's why you're seeing it pass in the lower environments but fail in the other environments. So yeah, getting that system of truth is so important. CI/CD is so important.
Absolutely. And just to add on one of the points that you were mentioning, Paul, about the 3 A's, I was doing my research when you were talking about it. The earliest reference to it that I could find was at Mark Simpson's blog, which is defragdev.com. So people can actually read the fundamentals of unit testing there.
I found my note on that, Smita. So it was Bill Wake, and I should have known that.
Bill Wake. Yes.
Bill Wake says that he coined the term in 2001, and that it was used again in Kent Beck's TDD by example book that I mentioned earlier. But I really love this concept, the 3 A's: arrange, act, and assert. I love that concept. I've liked it for a long time. And I think it's a big reason why BDD works so well within Gherkin, because you have the same concept. So instead of arrange in BDD, we have given. And then instead of act, we have when. And instead of assert, we have then. So those line up really, really nicely. And there's several other paradigms that line up nicely with that as well.
Yeah, and I actually, yes, that's probably my bad. But I did like this reference on Mark's blog, which kind of defines it very well, the 3 A's.
That's
now,
awesome.
Here is your final question. So somebody's asking you, hello, could you do another webinar for automation test of infrastructure as a code and database as a code? Now, that's a request, but the question there is there are there some specific or automation testing tools to automate infrastructure as a code testing? Are there any specific tools for them?
Yeah, I think I'm understanding that right. So infrastructure as code. So basically all your orchestration tools that are out there, there are lots of tools for that. Do you think I'm on the right path here with what they're asking, Smita? Things like Puppet and Ansible, and even a lot of the stuff out on AWS, Kubernetes, and all kinds of stuff out there for orchestrating. So the word orchestration just means how are we going to set up our infrastructure? And there are lots of ways to do that programmatically. In fact, lots of the cloud providers, since so many folks are in the cloud these days, have APIs that you can call into that will set up your environment for you. Docker would be one example in my mind of setting up infrastructure. So you can set up your Docker file to have the right information for how your system is supposed to be built. That would be a part of the infrastructure. If you're talking about physical infrastructure, I have no idea. Logical and up from that, logical, virtual, and all that, I think hopefully I've hit on kind of well there.
Yes, perfectly, because I think the cloud part of it, sorry to cut in, the cloud part of it, you probably responded to that. In the hardware perspective is probably out of our scope right now.
And I would love to do some kind of talk on that. These things, whenever you get into actual demos and code and all that, it gets much more time consuming to create a workshop or to create a talk about it. So I tend to avoid those to some degree. I love doing them and I love getting involved and learning those things. And yeah, I'd love to do one of those maybe here, maybe over on the beaufortfairmont.com/webinars group of webinars. But that's a great idea. And hey, whoever asked the question, if you have content like that, I'd love to see it. And I'm sure STPCon would love to see it as well.
Yes. So thank you, Paul. Thank you so much. It was a very insightful session on simplifying test automation, and many thanks for sharing all these details. That really helps a lot. I'm sure our attendees found it very informative and useful too. So thanks again, Paul, and I hope to see you at STPCon.
I'm looking forward to seeing you and meeting a lot of new folks at STPCon. Thanks so much for having me.
So thank you, everyone. This concludes our webinar for today. Thanks for joining, and thanks for asking questions and being engaging and making the most of the webinar for yourself and the whole group. And if you want to see more such sessions from speakers like Paul Merrill and wish to learn more about testing, do join us at STPCon Fall 2019. The entire program has been selected and announced. Do take a few minutes to look them up at stpcon.com. If you have queries on registrations, do email them at info@softwaretestpro.com. Stay tuned for more webinars and online trainings coming soon at softwaretestpro.com. And thank you, everyone. Have a great week ahead. See you all in Boston in September. And keep practicing your test automation. Thank you.